Hello, grade 10 learners. Our topic is on geometric means and geometric series. We have the following objectives for today's lesson. Define geometric means and geometric series. Determine the geometric means of a sequence. Find the sum of the first n terms of geometric sequence. And solve problems involving geometric series. Now let's start. Let us first have this activity. Find the first 5 terms of the geometric sequence if the first term is 1 and the common ratio is equal to 3. Let us illustrate this sequence. So, if the first term is 1, we just need to multiply it by the common ratio, which is 3, to obtain the next term. And that is 1 times 3 equals 3. And then we multiply again 3 by the common ratio, which is 3. Then we have 9. Multiplying again 9 by the common ratio, which is 3. There we have 27. And to obtain the last term, we multiply 27 again by the common ratio, which is 3. So we have 81. It means that the first 5 terms of geometric sequence, if the first term is 1 and the common ratio is 3, is 1, 3, 9, 27, and 81. The sequence 1, 3, 9, 27, 81 is an example of finite geometric sequence. The first and the last term of finite geometric sequence are called geometric extremes, while 3, 9, 27 are called geometric means. These are the terms in between the first and the last term of finite geometric sequence. Let us deal with the first example. Insert a geometric mean between 8 and 2. When one geometric mean is found between two numbers, it is called the mean proportional of the two numbers. In order to get the mean proportional of the two numbers, we need to use this formula. The second term, or a sub 2, is equal to plus or minus the square root of the product between the first term and the third term. So on this case, we just need to substitute the value of the first term and the third term to the formula. There we have plus minus the square root of 8 times 2. 8 times 2 will give us 16, and then we just need to get the square root of 16. And that is positive or negative 4. So it means that the geometric mean between the geometric extremes 8 and 2 is plus or minus 4. Let us deal with the second example. Insert a geometric mean between 3 and 45. So in order to obtain the geometric mean, we just need to use the formula a sub 2 equals positive or negative square root of the first term times the third term. We just need to substitute the values of the first term and the third term, and that is positive or negative square root of 3 times 45. 3 times 45 will give us 135. And then we simplify the square root of 135, and that is positive or negative 3 square root of 15. So it means that geometric mean between the geometric extremes 3 and 45 is positive or negative 3 square root of 15. Let us deal with example number 3. Insert two geometric means between 2 and 250. There are two geometric means needed in this problem. Let us first identify the extremes and the number of terms. So the extremes are 2 and 250. And there are 4 terms in the sequence. We can use this to identify the common ratio given by the formula R equals n minus k, the radical sign, a sub n over a sub k. The value of a sub n here is 250, and the value of a sub k here is 2. Substituting this to the formula, there we have 4 minus 1, which is the value of n minus k, and then the radical sign 250 over 2. Simplifying 250 over 2 and 4 minus 1, it will give us the cube root of 125. So the cube root of 125 is equal to 5. So it means that the common ratio is equal to 5. We can use that common ratio to multiply it to the first term. So the second term is 10, multiplying again 10 by the common ratio. So we have 50. So it means that the two geometric means between the geometric extremes 2 and 250 are 10 and 50. Moving on with our discussion, let us define what is a geometric series. It refers to the sum of the terms of a geometric sequence. For us to get the sum of finite geometric series, we will be using the formula S sub n equals a sub 1 times the quantity of 1 minus r raised to n all over 1 minus r. For infinite geometric series, we will be using the formula S sub infinity equals a sub 1 over 1 minus r. Try to deal with solving the finite geometric series. Example number 4. Find the sum of the first 7 terms of a geometric sequence whose first term is 2 and common ratio is 4. Identifying a sub 1, which is the first term, equals 2. N, or the number of terms, is 7. And R, or the common ratio, is 4. Substituting all these values to the formula, there we have S sub 7 equals 2 times the quantity of 1 minus 4 raised to 7 all over 1 minus 4. We need to simplify first the 4 raised to 7 and also the 1 minus 4. And it will give us 2 times the quantity of 1 minus 16,384 all over negative 3. And then simplifying what is inside the parentheses, which is 1 minus 16,384. And that will give us negative 16,383. Multiplying 2 by negative 16,383. And that will give us negative 32,766. We divide it by negative 3. So we have S sub 7 is equal to 10,922. So it means that the sum of the first 7 terms of a geometric sequence with the first term 2 and the common ratio 4 is 10,922. Let us have the fifth example. Find the sum of the first 6 terms of a geometric sequence: 15,625, 3,125, 625, and so on. So, on this case, we need to identify the first term, and that is 15,625. The number of terms, or n, is equal to 6. And for the common ratio, we just need to divide the second term by the first term, and that will give us 3,125 over 15,625, and that is, in lowest term, is 1 over 5. So it means that the common ratio is 1 over 5. Substituting all these values to the formula, there we have S sub 6 is equal to 15,625 times the quantity of 1 minus 1 over 5 raised to 6 all over 1 minus negative 1 over 5. So on this case, we need to simplify first 1 over 5 raised to 6 and also 1 minus negative 1 over 5. And that will give us 1 over 5 raised to 6 is 1 over 15,625. And 1 minus negative 1 over 5 is 6 over 5. Simplifying what is inside the parentheses, 1 minus 1 over 15,625, and that will give us 15,624 over 15,625. And then we multiply it by 15,625. So we can cancel this out. So the numerator will give us 15,624 over the denominator, which is 6 over 5. So on this case, we need to copy the numerator and then get the reciprocal of the denominator to simplify. So we have 15,624 times the reciprocal of 6 over 5, which is 5 over 6. So multiplying these two, the result is 13,020. So it means that the sum of the first 6 terms of a geometric sequence, 15,625, 3,125, 625, and so on, is 13,020. Moving on with example number 6. Marie saves 200 pesos in November. Each month thereafter, she manages to save twice more than what she saved the previous month. How much is Marie's savings after April? So we have to take note that the amount saved each month is 200, 400, 800, and so on. So on this case, the first term is equal to 200. The number of terms is 6, since the number of months from November to April is 6 months. And the common ratio is 2 because she manages to save twice more than what she saved the previous month. Substituting all these values to the formula, there we have S sub 6 is equal to 200 times the quantity of 1 minus 2 raised to 6 all over 1 minus 2. So we simplify first 2 raised to 6 and 1 minus 2. There we have 64 for 2 raised to 6. 1 minus 2 is negative 1. Then we simplify what is inside the parentheses. 1 minus 64, and that is negative 63. We multiply it by 200. There we have negative 12,600. Then we divide it by negative 1. So S sub 6 is equal to 12,600. So it means that Marie manages to save 12,600 after April. Now let us try solving some example of infinite geometric series. For example number 7, find the sum of the terms of the infinite geometric sequence 3, 1, 1/3, and so on. On this case, we identify the first term, which is 3, and the common ratio, which is 1/3. Simply substitute these values to the formula. We have S sub infinity is equal to 3 over 1 minus 1/3. So we simplify 1 minus 1/3, and that will give us 2 over 3. So to simplify 3 divided by 2/3, we simply copy the numerator and get the reciprocal of the denominator, and that will give us 3 times the reciprocal of 2 over 3 is 3 halves. And then we change the operation into multiplication. Now, 3 times 3 halves, that will give us 9 over 2. So it means that the sum of the terms of the infinite geometric sequence 3, 1, 1/3, and so on is 9 over 2. Now let us try doing this. Find the geometric mean between 1/2 and 1/8. Is it A, 1/3, B, 1/4, C, 1 over 5, or D, 1 over 6? What is the common ratio of the geometric sequence with the first term 2 and the fourth term 686? Is it A, 5, B, 6, C, 7, or D, 8? Next, insert two geometric means between 2 and 686. Is it A, 1498, B, 1050, C. 16,128, or D. 18,162. Next, find the sum of the first seven terms of geometric sequence 3, 12, 48. Is it A. 4,095, B. 16,383, C. 10,992, or D. 65,635? Lastly, find the sum of the infinite geometric sequence 45, 15, 5, and so on. Is it A. 68, B. 137 over 2, C. 135 over 2, or D. 69? Until our next session, thank you and enjoy learning.